Hi, friends, it's Dr. Bill, and this question that I'm going to look at with you is for fifth grade science teachers. So, if you have any colleagues who teach fifth grade and are struggling with what is called the SCR, the short constructed responses, I'm here to help. I've been working with this school district. They're doing the what we call the beginning of the year assessments, and they're using some of the release tests from last year and other years to see how the kids are performing at the beginning of the year so they can compare and contrast how they do at the end of the year. That way, the whole TIA, the teacher incentivized, teacher, what is that? TIA, TIA, teacher incentive allotment, whatever that's called. So they can earn pay based on the growth of the student. Now, the problem is if the teacher grades those beginning of the year responses, him or herself, there could be a tendency to grade lower so that the growth looks greater at the end of the year. There's also sometimes bias if somebody from within the district is allowed to grade those because there's a possibility that the that person knows the student and they're measuring their growth versus whether the student actually answered the question or not, or they might have a bias against that teacher and grade more leniently, if that makes sense at the beginning, so that it would be harder for that teacher to show growth. So a lot of schools or districts hire me to say, hey, can you analyze this product at the beginning of the year so that we can help our teachers have a true unbiased assessment of where a student's at, an x-ray of where the kid is at, so that when the year ends, we can truly measure growth. And so, of course, they end up usually having to hire me again. And so I've done this for science because this coming year there's going to be for those of you that are not aware, seven more 2-point non-multiple choice questions. Those seven questions are worth 14 points in one way, shape, or form. Now, the one I'm going to look at today is a fifth grade science question, as I mentioned, and I intentionally changed my picture in the background to a bathtub, an old school bathtub. And one of the things that you put in a bathtub, the main thing, the main ingredient is water. The scientific, since we're talking about scientific science, fifth grade, the scientific term for water is H2O. So I want you guys to think of the H as the hypothesis, the two as the 2 points your students can earn for either part A, part B, or the first point and the second point. And then the O is they're going to look at it and they've got to decide, oh, this person didn't understand the question or the topic. And so I turned the O into a little Q for a question and placed a T inside for the topic. And all of these 2-point questions usually have 2-part topics, if that makes sense. Okay. So this question we're going to look at is going to be from last year's question number 15. And, in this school, this district is paying me to grade their essays. And, I spend a certain amount of minutes analyzing them. And so what I wanted to show you was some correct and incorrect answers in terms of uh, this question based on the H2O strategy that I want to share with you. What's the hypothesis? Vary GPS, get pretty specific. How do you get the 2 points? What 2 things do you need to do? And then, of course, after the hypothesis is shared, there's a question that is asked, and a question has a question mark that usually asks things like who, what, when, where, why, which, or how. Okay, so let me show you my screen because a lot of people think that I'm only a writing, reading, editing, revising, or a math consultant. No, because all grade levels and all subjects now have what is called multiple choice or non-multiple choice 1 or 2 point questions. I'll be able to hear myself, and you need to hear me on my microphone test. We're going to check and see. This is going to be style, non-multiple choice style number 6 in my list. Now, if it's above this line, it's only based on a reading or writing question. If it's below the line, it can come from any of the other subjects. And so I've already graded 80 essays. And so what I'm going to do for you is help you learn from other people's mistakes on this more than one correct answer to a question. All right. So I'm going to break down the question using my transition, teeter, totter, seesaw, compare, contrast relationship. So the first thing that your students saw was the H of H2O, the hypothesis. Okay. This was 5th grade science, number 15. Okay. And just in case some of you were not aware, this is my understanding of how the scoring went. Only 27% of the kids in Texas last year got both points. They answered both parts of the question. Only 18% got 1 point for the first part or 1 point for the second part, but more than 55%, and that was my understanding because it was very hard to understand the item analysis reports based on the way they wrote them last year. But that's my understanding that more than half of the students in 5th grade couldn't even get 1 point because they couldn't answer part A or part B of the question. So let me come out of the document camera for a second, and I'll show you a simple way to teach your kids this concept of teeter and teeter, transition, totter. So part A and part B correct equals 2 points. Part A or part B equals 1 point. Part A nor part B is equal to 0 points. Now, from my understanding, when the two scoring engines look at it, kind of double check, they have to agree on these kinds of questions. In other words, they have to see and agree that both parts of the question are answered correctly, or that one part, or that no parts of the question are answered correctly. Sometimes, as you know, if it's the response is completely off topic or indecipherable, illegible, incoherent, of course the kids are more than likely going to get a 0, but it goes to a human because 25% of the humans are going to check that. So let's use this little water in the tub H2O analogy to help understand how it looks. So let's first look and see how was it laid out. Okay, a class is using the setup shown to test this hypothesis. And inside the box is the exact hypothesis. The very specificness of the hypothesis, that's the H of the H2O, is critical that your students understand. The shorter the stack of books becomes, there's the stack, comma, the shorter the distance the truck will roll. Okay. Now, this is the setup. 3 books, 1 marble on a ramp of that length. Okay. That length is important. Another book is on the other end of the ramp with a little toy truck that has a plastic cup sitting on top. So as you can see by the arrow, when the marble is released on the top of this ramp, it's supposed to go into the cup and cause the toy truck to move a certain distance. Okay. So the only things that you have to think about is the cause and effect relationship. Okay. So let's look at that. The cause, red, I'm going to use here. The shorter the stack of books becomes. Cause. The effect, the shorter the distance the toy truck will move. You can also think of it as an action reaction. I use green for that. The action. The shorter the stack of books becomes, in other words, remove books, then the shorter the distance the toy truck will move. That's the reaction. That's the hypothesis. Okay. Then they decide to ask a who, what, when, where, why, and or how. Because it's worth 2 points, your kids are going to see that word and in bold. What is one more piece of equipment needed to test this hypothesis? And how can it be tested? So what and how? Okay. Because the hypothesis is based on what a piece of equipment that needs to be added that's not already there, and how that specific hypothesis of distance can be tested. It's very interesting, some of the answers that I saw of these responses. Okay. So part A, part B. I needed to get A and B correct to get both points A or B correct to get 1 point. And if I got neither A nor B, then I would get 0 points. So what you might teach your students to do with H2O is H, what's the hypothesis? Well, cause and effect, the shorter the stack of books becomes, the shorter the distance the toy truck will roll. Action reaction, the shorter the stack of books becomes, the shorter the distance the truck will roll. All right. Didn't go very well. All right. 55 plus about 18, 65, 75, 73% either got 0 points or only 1 point. Okay. So again, the two-part question, two-part O, water. What is one more piece of equipment needed to test the hypothesis, and how can the hypothesis be tested? All right. So your students, in order to get a point, because we're trying to measure distance, that's very important, then part one, the piece of equipment that was needed was a ruler, a yardstick, a meter stick, measuring tape. And I saw some students in the school that I was checking, they talked about using line paper or graph paper. Now, that on its own is not going to help me measure. But when the student added the details to say, number each line on the line paper or the graph paper, because you want to be able to measure the length, all of a sudden that made sense. But the line paper or the graph paper on its own is not going to help me measure distance. Now, the second part, how can it be tested? Well, if you have one of these, then you can measure distance. You can measure length that it travels. You can measure the inches that it moves. You can measure the centimeters that it moves, the millimeters, the feet traveled. As long as your students had one of those cause and effect relationships, action and reaction relationships, they were going to be okay. Okay. A couple other acceptable options were that you repeat the test several times. Okay. Is maybe just doing this once, it might go a certain distance, but if you do it multiple times, then you would be having a more accurate hypothesis, because a lot of times repeated tests are what are required to make to test the accuracy of a hypothesis. Now, it's very important that this varying the book stack is on the how side, not the more equipment that can be added. Because this part here says the shorter the stack of books becomes, okay? So if you want to check and see if it's true, then yes, that's how it can be tested. But there has to be a clear distinction between the equipment that you're using and varying the book stack, which is that stack on the left. Do you make them thicker? Do you make them smaller? That's how you're going to test it. But because we're talking about measuring distance, the only equipment I can use to measure distance is some measuring tool that measures in either the standard system or the metric system of measurement. Okay. Now, here's some answers that would have gotten your students 0 points for part one or part two of the question. If you needed more books or less books are not going to help you. If that's the equipment that you need, that's not going to help you with distance in terms of how far the truck's going to roll. Another one, add another marble. That is not going to help you based on this part of the hypothesis. Adding marbles has nothing to do with the stack of books. It'll only affect maybe the distance the toy truck will travel by adding or removing marble. Well, you can't remove marbles because it has to be something to make the truck move. Okay. Another one. Somebody said a scale. Well, a scale or a triple balance is either going to measure weight or it's going to measure mass. Okay. That wouldn't be a tool to measure the length that something travels. Okay. Let's see what I have here. Another, what did I write there? Another, another cup. Okay. That's the amount of cups. Cups are not going to measure the distance, and the cup doesn't have anything to do with the shortness or the height of the stack of books. A different truck. Let's add a different truck. No, it said it's set up with these exact things. It doesn't say remove and replace these things. I need to add something to what's already been given to me here. So that's why this other one, this last one here, add a longer or a shorter ramp. Well, I've been given this ramp. So the only thing that we can add, the equipment, would have been some sort of measuring tool so we can measure distance. Okay? Some of the things that were ways that were wrong on how the hypothesis can be tested was you're going to measure the speed. No, speed does not affect distance directly. They had to make a direct connection between the speed of something and how far something goes. If they didn't do that, then they couldn't get the point. Okay. We're gonna check the weight. No, we're not gonna check the mass. Make the ramp longer, shorter, all none of those things on either side. If all they did was make a summary of everything in the picture, that's not answering the question. If all they did was repeat the hypothesis, the shorter the stack the book becomes, the shorter the distance the truck will roll. That's not answering the question. That's just repeating information that's already been given. So all those were reasons why your students got zeros on this particular question. And from my understanding, over 55% couldn't answer anything, and only 18% were able to get one of those points or the other. So I'm going to ask you to do me a favor, because most science, biology, social studies, US history, this school district has asked me to check all of their 2-point questions that they gave to the students from 5th grade and 8th grade, and I believe it was 9th grade, with biology and US history and science. All of those things are going to be checked. And I'm going to use my non-multiple choice form. That was this form that I used here. Let me show it to you one more time so you can know what it's called in case you ask me for it. It's called my readvising and writing graphic organizer. When you're writing open-ended responses that are non-multiple choice, you have to write them in sentence format. Now, it didn't really matter if the student wrote the answer to the question in two complete sentences or one. Some people will say, oh, you had to have the answer to the first question, part of the question first. No, you could have done this. In order to measure distance, there needed to be a ruler or a yardstick, a meter stick, or measuring tape, or some lined paper as long as they went and explained that. In a teeter-totter, it doesn't matter which side of the teeter or the totter you're sitting, as long as you're answering both parts. And so just like part A, part B, answer evidence, if I have the answer and the evidence, I'm going to get 2 points. And it doesn't matter which one was written first. If I have the answer or the evidence, I'll get 1 point. And if I have the answer nor the evidence, I will get 0 points. The only time that your students would get 0 points for a partial answer is this one right here, number 7, where it says multi-part, part A and B, where the answer to part B is dependent on part A, that your students can have the right evidence, basically, but if the answer is wrong, they're going to get 0 points. So please keep that in mind. You have to make sure that the answer is right in order to get the evidence. So yes, you can have the correct answer with the wrong evidence and get a point, but you cannot have the correct evidence but the wrong answer on these. That's why it says on my number 7 chart that the answer to part B is totally dependent and reliant on part A being correct in order to get both points. Okay, so that's all I have for you for my kind of like summary of last year's 5th grade question. If you are one of those schools where you're doing a beginning of the year and you would like me as an outsider, as an unbiased doctor of open-ended, non-multiple, short constructed points, whether they be 1 point or 2 points or 5 points, 10 points, because it's basically 2 different readers giving from 0 to 5 points each on how you organize, develop, and your convention. So hope you guys liked my H2O strategy. Reminder, what's your hypothesis? What are the specific details? What are the 2-part questions and the topics to make sure that they answer both parts? God bless you guys. Please, please, please share this with a 5th grade science teacher so that they can possibly use a T-chart or the H2O analogy whenever there's questions that involve a hypothesis that has 2 parts like that one did. Thanks you guys, and have a wonderful day.